Okay, guys, we are revisiting a topic known as projectiles. We talked about this last time we did quadratics. We're doing it again, but this time we're doing it in standard form, okay? So we're going to talk about projectiles. It's basically just doing word problems with quadratics, okay? A projectile is basically something you throw. So what we're going to do is we're going to look at how you can use quadratics and what we learned to find the height of that object, how long it takes to reach that height, and how long it takes for the object to actually land. And so that's what we'll be looking at. So I drew what is a projectile, just in case you guys need to have that recorded in your notes. It's an object that's falling under the influence of gravity, whether you drop it, throw it straight up in the air, or throw it up and over. Now, just so you guys know, we won't be calculating distance today. It's really always just going to be about time and height. It's all about time and height, no distance. I believe I printed this for you.
No, I don't have it.
Oh, you don't have the worksheet? All right. So what we want to do, though, even though I printed this for you, is you guys want to write down what each of these parts represent and what they mean. T is time. T is time in seconds. Okay?
So the two different T's isn't.
They're all the same. Yeah. There's 3 of them. T is time in seconds. Now this whole thing, not just the T, but H of T, that's your output variable. It's like your Y, okay? But what it represents is your height after T seconds. A lot of times you could just think of it as your final height, you know. So what this is, guys, is this is an equation where if you plug in a T value, like say 2 seconds, that equation will tell you how high the ball or whatever it is you threw is at that point. So if you throw the ball, you think, how high would that ball be after 1 second? You plug in 1 for T, calculate the outcome, and you'll know the height of the ball at 1 second. That's what this thing does. This is another height right here, but notice it's a H with no T next to it, and it's got a little 0 instead. What that means is that's your starting height. The starting height. So, you know, I mean, if you're throwing a baseball, right, it doesn't start on the ground, right? It starts from up here, and that affects the height of the ball, right? If somebody threw it from lower, then it would be at a different height at a different time, at a certain point in time.
And then you assume V's it's velocity.
It is. V stands for velocity, which is kind of like speed. But the thing is, guys, is that when you throw an object into the air, its speed is constantly changing. It's not constant, okay, because of gravity. If I throw this pen up in the air, it starts off really fast, but what happens is gravity pulls on it more and more and more until finally just literally stops, and the speed is 0, and then instantaneously starts to come back down, and it goes faster and faster downwards, right? So the speed is changing over time. Okay, what the V with the little 0 means is it's your starting speed. It's your starting velocity. Okay, we're only going to look at problems where it's a positive, just so you know. But for you guys who maybe might be interested, I could ask you other kinds of questions. If you throw it up like that, that's a positive velocity because you threw it up. What do you think it would be if I threw it down? That's a negative velocity. What do you guys think it would be if I just let it go?
Oh, just negative.
It would be 0. The starting speed is nothing, but gravity instantly starts to make it move, right? But the starting speed is 0. It started at nothing. Whereas if you throw it, it started at a speed in your hand. Yeah. Actually, that's what I bought those for. Years ago, 10 years ago, I did projects with this stuff where the kids would go throw the ball and they would calculate their starting speed and things like that. But anyway, Let's go ahead and continue. Now, there's one mystery number up here. You don't need to label it, but I'll tell you what it is. That negative 16, it's always going to be there. What that negative 16 is, that comes from gravity. If we were on the moon, that number would be different. The gravitational pull of a planet or whatever depends on how big the planet is. The bigger it is, the more it pulls. What this represents is the gravitational pull of the Earth is negative 32 feet per second per second. What that means is that it will pull something towards it at a speed of 32 feet per second every second. So like after 1 second is 32 feet per second, and then after 2 seconds, now the object would be going 64 feet per second. It goes faster and faster, right? The 16 is half of 32, and when they calculated this little formula, it just ends up getting cut in half. But basically, that number just comes from the gravitational pull of the Earth. Yeah.
You know how you told us about the 32 per second?
Yeah.
Is that where that whole theory came from? If you drop a penny off the Empire State Building, you could break someone's skull?
So, yes, that's true, but the thing is, it doesn't work. And the reason why it doesn't work is because other forces act against it. After a while, air resistance pushes against, like it's going so fast, air's pushing on it, and it can't go any faster. So no, it actually would not kill somebody if you dropped the penny.
Yeah, that's where that whole thing came from, right?
Yeah. Now, if you took air off of our planet and you went to the, like there's no air on our planet, you went to the top of the Empire State Building, but we still had gravity, it probably would kill somebody because it literally would keep speeding up until it was like a bullet. But air causes it to slow down.
If you drop the pen, though, it would actually kill someone because it's sharp enough object.
Maybe. I don't know. It does cut back on the air resistance. But if it tilted, you'd probably lose it, right? But if you can keep it straight, so we could practice it.
Oh yeah, we're gonna just drop kills on it.
All right.
If you drop
All right. So if an object is launched from the ground, oh, by the way, you guys, height is always going to be in feet, so you might want to put feet there. This number is based on feet per second. So our units will always be in feet and seconds. If we wanted to make it meters per second or meters per minute, that would change this number because it would be converted. But the point is everything we're doing is in feet per second. All right. If an object is launched from the ground level, then we know something. We know the starting height is 0. So let's write that. Now, the reason we're writing this is because you guys are going to be seeing some word problems today where they tell you this thing's launched from the ground, and I want you to know, oh, that means I need to put a 0 there for the H drill. All right? When an object lands on the ground, then your final height is 0. So when it starts on the ground, your starting height is 0. But when it lands on the ground at the very end, your final height is 0. Okay? So there you go. So we'll keep that stuff in mind as we go. Can I erase? By the way, what kind of an equation is this, you guys? Standard form quadratic equation, right? And on a standard form quadratic equation, what is that number? The y-intercept. So your y-intercept at the start on the ground would be 0. And this is like your y variable here. So when y equals 0, when you plug in 0 for y, what does it help you find? X-intercepts, the roots. So in other words, when I ask you to tell when it takes to land on the ground, how long it takes to land on the ground, what we're going to end up finding is the roots. Okay? We'll get to all that a little bit. Let's go ahead and jump in here. Example 1. All right. So on your guys' little notes handout here, I'm going to do the examples on the left. You're going to do the student practices on the right after I do the example, okay? So let's go ahead and do example 1. A bullet is fired straight up into the air from an initial height of 6 feet. So initial height, right? That's h0, isn't it? Okay? It's fired straight up into the air with an initial velocity of 900 feet per second. That's my starting velocity, right? So let's go ahead and write I think that's the first question, is to just write the equation. So write a quadratic function to model the bullet's height. So here we go. It's going to be, instead of h and t, we can use x and y. I think I'll do that for now, just for the heck of it. So it'll always be negative 16x squared or t squared, whatever the variable is. But now we put our starting velocity. What's our starting velocity? And then x represents my time in this case. And what's my starting height?
6 feet.
6. So that equation would actually model the height of the object at any point in time. Okay?
Could we still use H&T?
You could. So if you guys wanted to use h and t, you could write it like this. Same thing. I'll put both. All right, so I'm going to let you guys try your student practice one here. I'm not going to erase anything. Here's yours. Go ahead and do student practice one. Period, huh?
Yeah, no mistakes there. I'm waiting for it.
All right, I don't think Alexis is here today. Let's ask Kiana, what did you get?
I got
Good. So she put her initial velocity here, her initial height here, and that's it.
Wait, we don't put a unit on the last 3 or on the last 3?
No. No. And if you chose to do x's and y's, this would be fine also. It doesn't matter which variable you use.
Oh, because I started with the Y when I was.
Yeah, it doesn't really matter which variable you use.
During a test.
Matter of fact, if you're ever going to do a graph of these things, it's probably better to do x and y. What was your question?
During the test, which one would you rather?
That's a good question. So here's the thing. I think this makes more sense to our minds because h means height, t means time. But on your test, I know that they're asking an x and y. So you might just want to do both. This because it makes sense, but this because that's probably what you'll be looking for in a multiple choice test. All right. So let's move on to example 2. That was just kind of like a nice little beginning question there. I'm just asking you essentially like, okay, what's the equation? But that's just the first thing you have to do really. After you get the equation, you start doing stuff with it. So let's see what we're going to do with it, because we're going to use that equation to find some stuff about this projectile that's been thrown in the air. So I'm going to go back to my story now. In my story, a bullet was fired into the air, and we had this formula, right? It was y equals negative 16x squared plus 900x, and what was it? 6. Okay. How long does it take the bullet to reach its maximum height? Well, so I've got a picture over here to kind of help us get this. This is what this parabola would look like if I were to graph it. It has a y-intercept of 6. It's a sad face. Now this thing is asking us to find the maximum height. Can you guys recognize where that would be on the graph? Very good. It's the vertex. So basically what they're asking you guys to do is to find the vertex here. So the max height is at the vertex. So now in this word problem here, which variable represents the height? Y or x? The y represents the height. So right here we have our max height. What does the x variable represent? No. It's the time. Remember that? So you make sure you write this down somewhere because you'll want to see that. So this thing is saying how long does it take the bullet to reach its maximum height? In other words, it's asking for the x value of the vertex. Okay. Bonus point time. You guys ready? How do you find the x value of the vertex on a quadratic equation in standard
Okay,
form.
minimum or the maximum.
Well, yeah, but there's a way to calculate it. Yeah? That would be roots. That would be roots. Yeah? You got it. Very good. Nice job. All right. So last class, I think it was actually, we learned how to find the vertex. You do negative b over 2a. That helps you find the x, right? You plug it in to find the y. So here's what you want to do. When the question asks you how long it takes for the bullet to reach max height, here's what you're going to do. You're going to use this guy.
Oh, yeah.
Okay? That's how you find the time, the x variable, of the max height. So here we go. This is where calculators are going to come in handy. I went forward there. So get your calculators, turn them on, let's calculate some stuff. So we want to do, push your negative button here, parentheses, you probably don't really need the parentheses, but I'm going to put them on there anyway. 900, then push your division button. And then in parentheses, this one you do need parentheses, 2 times negative 16. And make sure you guys know there's a difference between the negative button and the minus button. Okay, the minus button is usually on the side. The negative button is somewhere down in the lower right-hand corner of the thing. So you have to have the 2 times negative 16 in the parentheses because then you're dividing the top by that whole thing. If you don't have this in parentheses, you're only dividing the top by 2.
Question.
Yeah.
Can you also do perfect? Let me see if I can you also just multiply bottom to 2 times 15?
And just do it mentally. That's fine. Yeah. All right. Push enter. You guys should be getting 28.125. So there's my answer. You guys should be getting 28.125, and that's 28.125 what? Seconds. Remember, we were looking for the time it takes. So now,
And then we multiply that by 900 feet because it travels 900.
you're close. So hold on a second. So let's recap. If I ask you to find the time it takes to reach the max height, what do?
Use that.
Find the x value of the vertex.
Which means use that formula, right? Negative b over 2a.
What is it? Seems like a circle.
Axis of, well, it's called, don't worry about it. It's called the axis of symmetry, though. Okay. All right. Now, let's go ahead and look at part B. Now, part B is a whole different question. Part B is asking us not how long does it take to reach the max height, but what's that one asking? What is the maximum height? They actually want to know this now, which is the y variable. How do you find the y variable of the vertex? You plug it in, right? So you take your answer from part A, and you plug it in to find the y value of the vertex, which is your max height. So this is where our calculators will come in handy once again. But I'm going to go ahead and type this in real quick. This is how you should type it in on your calculator, just so you guys know. It should have these parentheses on it. So if you guys want to get a head start on me and start typing, go ahead. But you would type in, you don't need the y equals. But you're going to push negative, and make sure you know there's a difference between the negative button and the minus button. So negative 16, and then put this in parentheses with a square on it. The square button looks like an X with a little 2 next to it in the top corner. Are we good? The square is like an X with a little 2 next to it.
It's like
It's right here. It's the 4th button up from the bottom on the far left side. You got it? What'd you get?
What? 12,662 feet.
So John got about 12,000. Let me see if I get the same thing. 28.125
Yeah.
squared plus 900 28.125 plus 6. 12,662?
Yeah.
Okay. So that would be 12,662.25 what? Feet. Now, just so you guys know, this is a little bit unrealistic. Let me tell you why. I actually looked up the speed of bullets. That's what they do fire at. Can somebody tell me why this is actually quite a bit more? No, because this function actually takes care of the gravity. So the function controls, it includes it. Huh?
Is there no friction?
That's the problem. This is like pretending there's no air resistance. So if there was no air resistance, but just pure gravity working on this, the bullet would literally go 12,000 feet, which is more than 2 miles up into the air. Now, that's not what really happens, though. What really happens is a bullet could probably go, I think I read, like maybe like anywhere from a half to a full mile straight up. Now, if you ever fire horizontally, they can go really far because that's the gravity, you know, is a little bit different. But the point is firing straight up, it wouldn't go that high because this formula does not take into consideration air resistance. Okay? So it's a little bit unrealistic. Now, when you're talking about something that's less extreme, like throwing a basketball, the air resistance barely makes a difference, and so you end up with an answer that's actually pretty precise. But when you're talking about something really extreme, like the speed of a bullet, air resistance makes a huge difference. All right, but anyway, so there it is. So let me ask you guys this again. If I want to find how long it takes to reach the max height, what do we do? X equals negative b over 2a. If you want to find the actual maximum height, what do?
You plug it in.
You plug that in. Good. All right, so you guys get to do your student practice here. Do part A and B. Danielle, what did you get for number 1 for 2A here?
2A?
Uh-huh.
Right.
How long it took to reach the max?
1.5625.
So it took about 1.5 seconds to reach its maximum height. Not very long. High 80's not with us today.
I know.
Nathaniel, what did you get for your maximum height?
Oh, fun.
That's a bad
370.1875.
Good. You probably did it right on paper, but something went wrong on the calculator. I'm not sure, but that's not quite it. Jonathan, what did you get?
I got 42.06.
42 point what?
06.
That I agree with. Now here's what your guys' calculators should have looked like, okay? For part A, you should have had negative 50, then a little fraction bar, parentheses, 2 times negative 16. That's negative b over 2a.
So, can I take this up after the whole class?
Oh, yeah, okay, go ahead. So Jonathan's going to give you guys a suggestion if this whole parenthesis thing is confusing you. Instead of putting this, what can you put instead?
You can just put positive 32. Negative. Positive.
No, he's actually right, because the double negatives cancel. So you could just put no negatives and just do b over 32. That would be fine. All right. Now, as for this one, here's what you guys should have typed into your calculators. You should have had negative 16, parentheses 1.5625 with a little 2 right there, plus 50 times 1.5625 plus 3. If you did that, you should have gotten 42.06. Now, if it's confusing to you guys to punch it all in at once, I like that because it's faster. But if you're having a hard time, then you can just do it piece by piece. Like you can square it first and then multiply it.
Probably confused me.
Huh?
Piece by piece would probably.
Yeah. It also takes a long time. So we have one more thing I want to do. So we've learned how to turn a word problem into an equation. Example 1. We've learned how to use that equation to find how long it takes to reach the max and what the actual max height is. Our final thing we're learning how to do is how long it takes to land on the ground. Now, when you're looking at these problem, guys, when it lands on the ground, that would be here, right?
Yeah.
Now, what do we call that part of a parabola?
Root.
That's a root. Now, how do we find the roots of a quadratic equation in standard form? That's true. I'll take that, Nelson. For y. Okay, I'll give you both that. But there's one more thing. Something very important that I really wanted you guys to remember. How do you find the roots of a quadratic in standard form? Huh? Was that you, Joanne? I hope. Was that you? I hope someone other than Joanne gets this. Because I ask this every day. How do you find the roots of a quadratic in standard form? Quadratic formula. I want you guys to remember that.
Because we cram so much knowledge into our brains every single day that I don't think it's possible for us to
Quit pushing that knowledge out. All right, here we go. Example 3. A bullet is fired straight up into the air, so we're back to my problem, so here it is.
How do you just remember all these numbers?
It's only 2 numbers to remember. No. All right, here it is. How long does it take to land on the ground? So I'm going to take what Nelson and Kayla said. They said plug in 0 for the h or the y, whichever variable you're using. So it looks like this, right? Now, you don't have to do this because it actually doesn't accomplish anything for us. Because what's the way I told you we're going to do this? We're just going to use a quadratic formula.
So that means we're going to use this.
No. We're going to use this old friend of ours. Oh, you guys made the wrong sound. Let's try that again.
Oh, that's actually not that hard anymore.
Still the wrong sound.
It's not that bad. It's just a lot of steps.
All right, the calculator's doing all the work. The calculator's the one that should be complaining. All right, what goes here?
That's Do you want the letters or do you want the numbers?
The number.
0.
16. 6. No, wait.
It's the B.
3. 900. 900.
Oh, we're doing the bullet. I have a headache now.
Okay. Here we go. Now, it's negative 900. Oh, by the way, before I go any further, another special note. You guys notice how there's 2 roots, right?
Yeah.
Which one do you think I care about? The one when it lands on the ground? I only want this one. I want the one that's farther to the right. So that's the bigger root, right? So in this case, when we do these problems, you don't really need to do this. You don't need to do the minus because that'll just give you the smaller root. We only want the bigger root. I think that'll rework. Let me see. You know what? I think it's the other way around. Actually, hold on. Yeah. You know what? We'll just do both because sometimes it'll be different. We'll just do both. Okay, so here we go, guys. What is 900 to the second power? I think it's 81 with 4 zeros on it. Now I need help. Double negatives here becomes a positive. But what is 4 times 16 times 6? Give me some calculator help.
54 times 6 is now. 384.
384. And on the bottom we have negative 32, right? Now help me out with the calculators again. What's 81 with 4 zeros plus, well, we don't need a calculator for that. That's easy. 810384. But what I do need help with is, on our calculator, we need to find the square root of this. Now, our calculator is just going to give us a decimal answer, you guys. So, let's see what your guys' calculators look like.
It's like
Okay, so what you're going to do is you're going to push second. So push second.
Wait, what?
On your calculator, push second, and then find the x squared button. But now since we push second, it's not going to do x to the second power. It's going to do the square root for us. So let's type in 810384.
Mine says error.
Um, equals. And I have here 900.213. There's a lot of numbers there.
I'm trying to. Wait, what is that bottom one?
I didn't get that like at all.
Me neither.
Okay, let's try it again.
No.
Maybe I did
That's
something
what
wrong.
I got. That's what I got too.
Okay, let's try it again. Push second. Did you guys get push second yet?
I didn't say it. I said what did you say?
Now find your x squared button and push that. Now you should see a square root symbol on your calculator.
Oh, there it is.
Now type in the number 810384.
Boom.
Close your parentheses and push equals.
You don't have to close your parentheses. Yes, you do.
You actually don't. You actually don't.
Yeah, argue with me again.
Stop making us do all that extra.
Yes.
Was it 1.123?
Yeah, one
Okay.
way is 213.
213. Okay.
Wait, I saw that.
Where did it go?
Right there.
All right, here we go. So at this point, guys, we want to write it twice.
Oh wait, we're not done yet?
Oh, 213, right?
We're not done yet?
No, we have to find the answer. We're still working.
I'm running out of room.
Okay.
Wait. That one's right there. So you wrote like right next to it. Can we
Yeah,
write
it's
that
supposed
one?
to say
We
213.
already wrote that one, right?
No, well, what I did was I wrote it again, but one was a plus now and one's a minus, so I split it up.
Oh.
All right, so if I add these, I'm going to end up with negative 0.21, no, positive 0.213, actually. If you guys add these on your calculator, you don't have to. I'll just tell you what the answer is. It comes up to be 0.213 because the 900s basically cancel. This one over here, like this, John?
Yeah, I mean, you have to divide.
All right, now we divide them. So
That's gonna be an ugly number.
what is 0.213 divided by 32? Negative 32.
Wait, which one is it?
Negative 0.006656.
That's good. All right, how about this one?
I got negative 56.256.
Okay, I'm going to double check.
Wait, we got two.
I know it's supposed to be positive.
56.2566.
So, same thing.
26.2566.
56.256. Okay, now, we want the bigger one, right?
That's the 6 on there.
Remember how I told you there's two roots, but we want the one that's further to the right?
Yeah.
So we want the bigger one. Okay. Now here's a question. I'll give you 2 bonus points if you can answer it. That's 56.256 what? Yes? It's seconds. Why is it seconds? Because remember, we were looking for x, which is time. We were looking for the time. So let's go ahead and put seconds on there. So supposedly, the bullet would take 56 seconds to land on the ground. All right, so let's review. You guys ready? If I want to find how long it takes for the bullet to reach its max height, what do I do?
You do the negative b over.
Negative b over 2a. If I want to find the max height, what do I do? Plug that in. If I want to find how long it takes to land, what do I do? Quadratic formula. If you guys got those 3 things, then you're pretty good for the day. That's all we are doing. So, I don't know how we're looking on time here. We got plenty of time. So, I'm sure you guys are more than happy about that. All right. I want you guys to try to find how long it would take your water bottle rocket to land on the ground.